All right, so in this first problem, looking at the SAT composite scores, they ask you what score would a student in the 50th percentile score. So if we think about what do we have on our x-axis, we have the composite scores, and on the y-axis, we have the percentiles. So they want us to look at the 50th percentile. So if I think about going from the 50th percentile and across, and I can get that lined up, then I can use my vertical bar here to help me get it lined right there where it crosses the graph. I can see that I am hitting right at this point right here. So I got to think about, well, what is that? So I'm going from 1000 to 1200. This would make the middle one 1100, which would mean that right there where it hits should be about a score of 1050. Now with the second problem, they're asking you to look at the 95th percentile. So again, we're going to take it up to the 95th, which is way up here. Going to straighten this out. And we can see we're aligned there. So now we're going to take our vertical bar and get it aligned as close as we can. And we can see it's really close to hitting right here at this point, which when we look down is right at 1400. So a score of about 1400 would be in the 95th percentile in the SAT. And the last problem here asks about what about a score of 950. So instead of starting with the percentile, we're going to start with a composite score of 950. So we have to remember that these are in increments of 50, so this is 900. So the next tick mark over will be 950. I'll try to line that up as well as possible. And then I'm going to look, where does it cross and hit that graph? So now I'm going to make my horizontal line here and see that it is right about the 30th percentile is where it's crossing. Maybe a little higher, but we could say about the 30th percentile. Now with these next problems, we're using the normal distribution to help us out. So in this one, it's asking that if a student's score fell at the mean, what would be his or her percentile? How do you determine this? So the mean is right in the middle. And because the bell curve is symmetric, we know that that means that 50% is to the left of the mean and 50% is to the right of the mean, which would mean that they would have to be in the 50th percentile. And if I summed all the values to the left of the mean, they would add up to 50%. Now, the second question says that a student fell 1 standard deviation below the mean. So we're going to look at 1 standard deviation below the mean, that is right here. And we're going to know what percentile. So we're going to add up all the percents to the left and see what we end up with. So everything to the left, that's 15 hundredths plus 2 and 35 hundredths plus 13 and a half, which would give us the 16th percentile for 1 standard deviation. That means they scored better than 16% of the students that took the ITBS test. Now, on this third question, it says if a student fell 2 standard deviations above the mean, what would his or her percentile be? So if we go 2 standard deviations, we're right here. So that is all these values to the left that they scored better than. So you can either add up all those values, or you can also recognize that if I take the values to the right and subtract them from 100, that will give us the same percent. So you can take it either way you want. So, but if we add up all those values to the left, so that would be 15 hundredths plus 2 and 35 hundredths plus 13 and a half plus 34 plus 34 plus 13 and a half. That will take us to the 97 and a half percentile. And then the last question, it asks that a student says that she found out that she scored the 84th percentile and wants to know how many standard deviations did the student fall, above or below the mean. So the 84th percentile, let's use the fact that we know that automatically the mean is the 50th percentile. So we're already 50% of the way there. What we need is another 34%. Well, if we go one more standard deviation, that is another 34%. That when together, that adds up to 84th percentile. So that means that the student was one standard deviation above the mean.